Hello, welcome to this video. This is 6-3. We are talking the trapezoidal rule, and the shapes here that we're going to be using to integrate with are trapezoids. You guys like my Christmas lights here? Feliz Navidad, Happy Hanukkah, Happy Kwanzaa, whatever you celebrate. I hope you're enjoying the holidays, as this video should be utilized in December, at least if you're using Essentials of Calculus. All right, so without further ado, let's go ahead and learn about the trapezoidal rule. For most functions, using trapezoids to approximate areas is more accurate than using rectangles. And the area formula for trapezoids, since it's more accurate and you'll be utilizing it, is the height times base 1 plus base 2. So you'll notice here we have a trapezoid, okay, and the area formula is height times the sum of the two bases cut in half. So you're kind of like averaging the bases, okay? So for integrals and areas underneath curves, we don't really have images that look like this. So what we do is we kind of rotate our trapezoid to look like this, and we'll just change the linguistics of it. Is we have height 1 and height 2, right? So we'll average those and we multiply by the width, okay? So let's go ahead and check out some examples, okay? So, and then again, here's the formula. So adjusted with the kind of terminology that we want. Okay, so they say, example 1, approximate from 0 to 10 the integral of f of x dx by adding the areas of the five trapezoids shown in the graph at the right. So what we want to do, we want to go ahead and approximate these areas. So again, okay, so the integral from 0 to 10 of f of x dx is going to be approximately, I'll make sure I use approximation, and it's going to be approximately, well, the area of the first area. So notice it's a triangle, but since we're talking trapezoidal rule, I'm going to use specifically that formula. So 1/2 times the width, which in this case is 2, times the average of the heights. So the height, the first height, which is here, and for simplistic sake, I'll call this h sub 0. H sub 0 is 0 plus height 2, which is here. I'll call this h1, which is 2. Okay, plus the second area. Okay, so I'm again going to take 1/2, and I'm going to multiply by the width, which in this case we go from 2 to 5, so that width would be 3 times again. Okay, so I want to average these two heights here. So again, it's h1, which is 2, plus this height here, which is 3. You know, and I made a mistake too. h1 is not 2. That's the x value. The h2 is 4. Pardon me. Okay, so notice I'm going to change it here, and I'll change it here. So 4. Okay. Plus, now I'm going to take area 3, so this height, okay, so 1/2 times the width, which is 1, times the average of the heights, so the summation of the heights. So again, I'm going to use h2, which is a height of 3, plus this height here, which is 2, okay. Plus now area 4, so 1/2. And notice it's a rectangle. Again, I'm going to use the trapezoidal rule. So the width here is 6 to 8, that's 2, times summation of the heights. So this height is 2, plus the next height, which is also 2, plus, okay, and then the last area. So again, 1/2 times the width, which is 2, times the heights. So height 1 is 2, height 2 is 5. Okay, so here is your answer. And again, that's numerical, so we don't have to compute that. Okay, and I kind of stopped doing this, but I want you to see, and we'll talk about this in a second. But I used these different heights, and I gave them different kind of sub designations. So H5. Okay, so there is the formula. So note the area formula for a trapezoid also works for a triangle, and I used that here, right? Height sub 0 here, I identified as 0, okay? And it also works for a rectangle, right, where the heights are exactly the same. So if you forget the formula for a triangle, you can always draw your areas as rectangles and triangles. So this is kind of like if you're stuck and you don't know how to calculate this area, right, I can always piece this image off into a triangle and a rectangle. Okay, so for example 2, it says use 4 trapezoids of equal width to find an approximation for the area under the curve of y equals x squared. Okay, so y equals x squared, that's going to be 0, 0, 1, 1, 2, 4 if I square that, right? And that looks like this, just a basic parabola. Here's y equals x squared. Okay, bounded below by the x-axis. Okay, so they want here. And on the left by x equals 0. Okay, so from 0 to on the right by x equals 2. So this bound, okay? And they want us to sketch the curve and draw the trapezoids first. So if I want 4 equal kind of subdivisions, okay, then what I have to do is I'm going to split it. So here's one, here's another, and then here is my last one. So notice I have 4 different trapezoids, okay, and okay, I did that. So what I'm going to do here is I'm going to go ahead and approximate this. Okay, so the value is going to be 1/2 times. Okay, and I want you to notice here, so I'm multiplying the area of a trapezoid is 1/2 the width. So notice here we had all these different widths, but in this problem I have equal widths, right? Each width is 1/2, right? So all of these values are 1/2, okay? So what I'm going to do is I'm going to factor this out, and it'll help us simplify our calculation. So 1/2 times 1/2, okay? And I'm going to multiply now by the summation of the heights. So I'll take this first value here, okay, which is h sub 0, I'll call h sub 0, and that height is 0, plus the second height, okay, which this is 0.5 squared, okay, 0.5 squared, or 1/2 squared, right, so 1/2 squared, that's 1/4, okay, 1/4, okay, plus, okay, again, now I want the summation of these two heights. Okay, so 1/4 plus this height. Well, what's 1 squared? 1. Okay, plus, now I'm again going to take the summation of these two heights. So 1 plus, this is 1.5 squared, so or 3/2 squared, and 3/2 squared is 9/4, just so you know where that 9/4 is coming from. Okay. And then again, now I'm going to take the area of the last curve, right? So, or the last trapezoid, 9/4 plus this height, which is 4. Okay? And what I'm going to do here is I'm going to kind of condense this, and I want you to pick up on a pattern. So 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus 4. Okay, and there is your answer. And I wrote it like that for a reason. I'm helping you develop the trapezoidal rule, and that is on the next page. When using trapezoids for approximations, if the subdivisions produce equal widths, then we have this formula. Okay, so our formula is 1/2 times the width times h sub 0, where h sub 0 is your initial height. So say my integral is starting here, right? This is a, my lower bound, and then I'm going to go all the way over here. Okay, well, my next height is h sub 1, right? So I have h sub 0 plus h sub 1, but for my next interval, notice, again, I'm going to be sharing that with this interval here. So it gets used twice, right? And then when I add the next interval, I'm going to end up sharing this bound twice, right? So on and so forth up until our last value. So you'll notice in this last example here, right, my h sub 0, my first height, I only used once, and my last height, I only used once. But every other value in between, it gets shared twice. Okay, so that's how we kind of develop this trapezoidal rule, right? So where we're multiplying by two, right? So there is the trapezoidal rule. Okay, so what about without a graph? Let's look at another formation of a function, and that is a table of values, and this should go pretty quick. It says use the trapezoidal rule with 4 equal subdivisions to approximate the area shown. Okay, easy enough. So I'm gonna have 1/2 times the width. Well, notice all these widths are 10. Okay, times, well, the summation of the heights. Okay, so I'm starting out with this value at 10 is 1.8 plus 2 times the next value, which is 2. Okay, plus 2 times 2.5. 2 times 2.5. Flustered because I'm running out of room. 2 times 2.5 plus 2 times 3.5. 2 times 3.5. Okay, and plus 2.2. Okay, and there is the trapezoidal rule, and there's your answer. All right, that's it. That is the trapezoidal rule. All right, I hope you enjoyed the video. I'll catch you next time. Peace.